All right, now we're going to take a look at the second page. The second page is going to be a little bit problematic uh, because I don't have the values for the change in enthalpy that I had on the previous page, since I did not bring the handout with me, and it came out of a book that I left at school. So I'm going to have to talk you through it, but I can't give you absolute answers on this. First one I can. All right, so we got on the first problem here. Now we've got zinc nitrate. We're mixing it with HCl, or excuse me, sodium hydroxide. So that's pretty simple. You just write the equation. So you got zinc nitrate, and the problem looks like that. The formula looks like that. I mean, plus NaOH. That's a double replacement reaction. So you get zinc hydroxide and sodium nitrate. And then you got to go back and check your charges and formulas and everything. So zinc is +2 and hydroxide is -1. So you'd have to have parentheses and a 2. That's 1, that's 1. So that's even. Put a 2 here to balance, put a 2 here to balance, and there you have it. Okay, you've got 3 liters of 0.5 molar. So what does that mean? 3 liters, 0.5 moles per liter. So really we're looking at 1.5 moles. On this side, you got the same thing. 3 liters and 1.5 or 3 liters, 0.5 liters of 3 molar. It's not quite the same thing, I guess, is it? So 0.5 liters times 3 moles per liter, but the bottom line is you still got 1.5 moles. All right, so take one, compare to the other. So if I did this one, that's NaOH. All right, multiply by, what is it, 1 zinc nitrate for every 2 NaOH. So that equals 0.75 moles. So about you have more than 0.75 moles. You need 0.75 moles of zinc nitrate. Zinc nitrate. All right, and you have way more than that, so that's extra. So the NaOH is limiting. All right, once you know the NaOH is limiting, and you're looking for the, that's it. NaOH is limiting. That's all this question asks, which is limiting. There you go. Okay, the change in enthalpy, you know you're going to use delta H equals the heat of formation of products minus the heat of formation of the reactants. And this is the one that I cannot do for you because I don't have the table of thermodynamic values for these guys. So I'm going to leave that one for you guys to do. You'll have this plus 2 times that in brackets minus whatever this is times 2 times that in brackets. Okay. Now, it's conditionally spontaneous. To know if it's conditionally spontaneous, let's think about that for a minute. This is aqueous. So we could say that's aqueous. This is aqueous. That's solid. And that's aqueous. So what's happening to the entropy? Is it increasing or is it decreasing? Okay, so we know that entropy is decreasing because you're going from 2 things in solution to a solid in a solution. So overall, there'll be less disorder on this side. So you would expect that delta S is negative. But delta H is also negative. So now you know delta G is equal to delta H minus T delta S. We know T is always positive, so we got a negative number minus a negative number. Well, so that means if this is a big number, if this is big, then that would shift delta G to be positive. If this is a small number, then delta G will be negative because a negative delta H, this value, minus a small delta S number would still be negative, and that would make it spontaneous. But if this is a big number, a negative number minus a big negative number is going to make that shift to be positive, greater than 0, and that will be positive and non-spontaneous. So it's spontaneous if this number is small. So how do you make this small? Low temperatures. So spontaneous at low temperatures. Okay, after the reaction is complete, the precipitate resulting is put into a new container to be exposed to HCl. The precipitate was zinc hydroxide, so that. And we combine that with HCl, and we get zinc chloride plus water. Okay, is this balanced? No, I don't think so. So we got to put a 2, H2O. We got to put a 2 here, and then you got to put a 2 in here also. Okay. Now this is HCl is gas. By the way, did you notice up here the pressure and temperature were not relevant because there was no gas. Down here there is a gas because the HCl, it tells us is gaseous. So we need to find out how many moles of HCl we would need. And up here, we know the moles of precipitate. I did not take time to work that out. So we learned up here that the NaOH was limiting. So if I took the 1.5 moles of NaOH, I'm going to put it right here for this because of room. So 1.5 moles of NaOH on the bottom, zinc hydroxide on the top. There's 1 for every 2, so it equals 0.75 moles of zinc hydroxide. So down here you're going to have 0.75 moles of that. So the moles of HCl will be twice as many. It'll look like this. So you'd have 0.75 moles of zinc hydroxide. And you know there's 2 HCl's for every 1 zinc hydroxide. So that equals 1.5 moles of HCl. So now, in our PV equals nRT formula, we know that the N is 1.5 moles. Doesn't say anything about, it says assume dry gas, so we don't have to worry about adjusting pressure, so we have 1.4 atmospheres. We don't know the volume, we're looking for that, let's put a V in there. Since we're in atmospheres, 0.08205 liter atmospheres over moles Kelvin. And the temperature would be 303 K. So then you just solve for V. So let's do that. 1.5 times 0.08205 times 303. If you're doing it with me, that's 37.291725. I'm going to round or divide that by the atmosphere. The pressure in atmospheres is 1.4. So our final answer would be 26.6. So V is equal to 26.6 liters. And that's how you did that one.